Right. I think this is a very exciting piece. As Sudheer already talked a lot about, especially why we get fewer tickets. It's all about this self-driving, and I can totally understand for most of people, first time driving network, you will say, "Oh, it's marketing." It's not going to be true. Yeah, it may be true for some other vendors, but certainly not the case for Marvis. We build Marvis not only on this PowerPoint. We actually build Marvis in the selling product running for the Fortune 10 and Fortune 100 customers. So you can see here, there are three big parts. We talked a lot about telemetry data, but in addition to that, we really build very complex data pipelines, which can really process hundreds of terabytes of data every day collected from various types of the devices. In this step-by-step, like you can see in the data funnel, it's really with a mix of the streaming, mini batch, and batch processing. Like I talked to you, but one thing I want to highlight here is that root cause. Like I talked in the announcement example, we don't want to just send you the model result, which is noisy, which is not actionable. Marvis is really focusing on finding the root cause of the problem. Why? Because the root cause normally leads to the remediation action. And there are three types of the actions that actually Marvis does. The first one is the self-driving action. If the root cause is within Mist or Juniper devices, we just take care of it. We remediate the problem even before your employee complains to the help desk. That's why we got fewer tickets in the deployments. But in addition to that, if the root cause, sits, we actually does. I remember there's a good question. For the surrounding system, we don't have data coming from all of the, the whole IT system. But based on the user behavior, we can do the inference. If most of the user fail connection to the network from our observation because of DNS, do the correlation and the reasonable infer, there may be the problem with the DNS server. So this is what we call as this driver-assisted actions. In that case, we give users the suggestions. Marvis does the inference and give users a suggestion to guide the user step by step to resolve the problem in the adjacent system. And for the remaining, I'm not saying Marvis is going to solve all of the problem. Still, there's a long tail. There's all different variety, especially client-specific problem, all of this. For the remaining 5 to 10% of this long tail problem, that's what we give you. That's the reason we build this conversation interface. We will give all of this AI insights we learned from Marvis, and we will deliver that to you in just a simple NLP interface. So next, we're going to talk about a couple examples, real-world examples, really how we solve almost like 2 decades old like networking problem through the self-driving network. First is this radio management.
Jisheng, can I ask you a question?
Yeah.
So in the previous slide, you talked about collecting telemetry. I'm assuming that telemetry comes only from your network, right? So there's a big push from CNCF about open telemetry, but that's specifically to application infrastructure space, not necessarily in the network space because there is no standardization across. Is there an equivalent initiative of the open telemetry in your space? And if so, how and who and what is happening? I'm not aware of that.
I mean, I think 2 points I would point out there is one is we do ingest data from other third parties, like Sudheer said, the LRDP, we can ingest data from Cisco Aruba switches. In the industry side, I'm actually working in the ONOG group right now, which is an initiative to see how we can basically help AI ops ingest data from multiple cloud vendors, if that makes sense. I mean, so I think you're right. I think we're going to see the industry start moving data about how do we make sure your AI ops solution can actually ingest data from multiple sources.
Right. Which brings up a related question, which we may not have time to discuss here today, but I'd love to talk to you guys. So on my day role, I'm an analyst, as some of you know. I'm doing an observability report right now. I'm talking about 22 vendors in the observability AI ops space. Most of them seem to be in the application and infrastructure space. One of the major problems they have, whenever I ask them a question, they claim to be a full stack observability, but none of them have the network data, not from any of the vendors.
Right.
So even though they are able to find a correlation related things, it's still in my mind a partial data because it's very specific to system. I mean, the the metrics logs and the golden telemetry what you use is exclusive of network data. So that's a lot of conversation I want to have with you guys on how these things relate, maybe sometime, not necessarily now.
Yeah, so that's something I'd love to follow up with you, because right now I'm active in the industry right now, trying to see how we can help basically solve the problem of how do we ingest data from multiple sources, multiple cloud vendors.
Yeah, and that, kind of somewhat related to Andy's question though, is which system or which vendor or what becomes the single source that I go to for that intelligence?
I don't think, Tim, given talking to Gartner, talking to the industry, I don't think it's going to be one ring to rule them all. I think you're going to see distributed domain specific. If you talk to Gartner, you'll talk about domain specific AI ops, domain agnostic. I think you're going to see multiple AI ops systems sharing data across each other, depending on what question you want to answer. So I think it really starts with what question are you trying to answer in AI?
Yeah, but I guess okay, so I hear that, but at the same time, so I look at things from that customer perspective, from that customer lens, and that scares me. That scares me from the perspective of, great, so now I'm not sure if now I have to make sure that if I'm asking the right question of the right vendor or of the right solution, that gets really complicated, and we're just talking about network, right? We're not talking about the other aspects of infrastructure that come into play. And frankly, this goes beyond just infrastructure, right? It goes into supply chains and applications and the rest. So if you're saying that, I realize that we may be in the early days of this, and maybe this is just a maturing process that needs to take place, but it kind of gives me a little bit of concern.
I think, Tim, actually your concern is completely well-founded, and that's where Bob's been going pillar to post, trying to figure out, guys, we got to at least get data in normalized, the schema normalized. So at ONAG, Open Networking User Group, Bob's been championing that. He's working with Gartner and other teams. But I think your concern, I think, is well-founded. That's where we are in the industry right now, and we have to get to a better place as an industry.
If I may add to it, there's also a couple of other little wrinkles into that, right? One is, the industry as such, where we're moving into, particularly with the hyper infrastructure, the infrastructure abstract networking. So there is no need for, when most of the infrastructure vendors provide that infrastructure, no need for you to go detail into network. So they kind of try not to give that information or get into detail. And the secondary issue is, from what I've seen, there are initiatives, particularly CNCF, very geared towards infrastructure space. So they are trying to do this open telemetry standards and others to have incubating projects. But there is no one in the network space to do that unless you come up with your own stuff or even have CNCF go towards that. So it's going to be a catch-22 situation.
Yeah. We agree, and we'd love to partner with you, Andy, and the other players on the infrastructure app side, because right now we feel, from a network perspective, from a client to cloud perspective, we have all the data, but to your point, we have network data. They have app data, and to Tim's point, somebody else has infrastructure data and supply chain data. And so, I think that's the initiative. I think as an industry, we got to converge and move forward.
Agreed.
Awesome. All right. So I think maybe very quickly, in the interest of time, we'll hit on a couple of these examples, right? So as Jisheng said, this is our ability to, maybe Bob, you've started RRM many moons ago. I'm going to actually have you lead this.
So RRM has been around for like 20 years. So I did RRM back in aerospace. 20 years ago, we were basically trying to optimize the power between devices. That was kind of our interference optimization. What has changed in those 20 years is now we have things like reinforcement learning. And we're not optimizing the power, we're optimizing the user experience. So these RRM algorithms are now basically trying to optimize the connection between the user and the access network, right? And trying to make sure it's symmetrical. And that's reinforcement learning. So that's been the big change in the last 20 years since I've been here, that gives you better experiences. And I think you'll see, if you talk to some of our big customers who have tried it, they're starting to see the RRM actually start to work for the first time that they've tried it.
Yeah. One of our customers, very quickly, example, they run a 10,000 AP. They're a fast food retail chain, I'm sure a friendly name for all of us. And so 10,000 APs, they manually used to configure 40,000 parameters, power and channel on each radio, 40,000 parameters with Juniper Mist. Their nirvana is, and it like you deploy it, you just set it, forget it. In fact, you set nothing. Out of the box, it just works. So we're definitely experiencing the notion of using user experience for that. Jisheng, if you can quickly hit this.
Yeah, I think Bob and Sudheer, regarding this radio management, Bob and Sudheer talked about really the self-driving piece, actions. We continuously monitor, adjust the parameters in the environment to optimize the user experience, user reinforcement. But what if the root cause is not inside the radio, or it's not inside us? For example, some misplaced AP. People, contractors put the AP at the wrong place, right? Or this like insufficient capacity, they don't have enough there. This is actually this driver assisted actions. This is called a coverage hole. If you look at the graph on the right, actually not those like red colors are just the APs facing the low coverage. Not every of this low coverage area is a true coverage hole. If you look at the right top, there are 3 APs there continuously with low coverage for the clients there. But just because these APs are next to the parking lot, so these are normally the last AP clients connected to before they feeding away from network. They expect it to be low coverage. So in this case, we actually use some of the graph analytics. Like between this, we actually build a very large graph using the scan data across all of these APs for each site. Then we look at the betweenness, the centrality, and all different graph metrics to really identify the role of each AP. Is this a transitional AP, or is really this a busy serving APs? And based on that, you can see we actually can reduce 90% of false positives. A lot of the AI work we do is to just reduce the false positive. Because if you send one noise with one like true alert, 50% accuracy, then no one will really take actions based on your AI. So we reduce 90% of false positive in this detection. And really now we're running beta tests in a Fortune 10 customer environment.
Yeah, no, so, this is good.
Jisheng, so as I think of this, kind of coming to the work from anywhere, work from home perspective, how are you kind of tackling that? So let's say I do want to start deploying Mist to my employees and to my staff that might be working remotely. I mean, is there some intelligence? Because this is one of the core issues that people have with their home networks.
So I would say, Tim, again, everything we can do with Marvis in an enterprise setting, we're doing at home. Truly, we've seen so many examples, real world examples. So a lot of the conversational interface to solve problems, getting, what's plaguing your network, why is your Zoom call bad, all this kind of questions, Marvis that can answer, we're answering and taking that to the home. So enterprise grade at home is sort of the new mantra for us, AI at home. And so, yeah, there's definitely a lot of value our customers are deriving from this. This particular example is an enterprise example, but even as simple as finding the best channel and best power to run at home and being able to support that experience at home, it's been good and critical.
Yeah, I'd be curious to see, maybe this is offline, but curious to see how this plays out in a work from home perspective, especially in a disconnected model.
Yeah, actually, this is a good example, of probably will be applicable even to the home environment. This is a 2-decade-old network problem called the Ethernet error. Some packet actually has an error packet from your network. So no matter in the home or enterprise, so normally when that happens, the user will feel the slowness at least, or sometimes even feel the connection. So I want to use this example also as the self-driving network to see how Marvis actually tackles this step by step. So when you see this are 3 different APs actually has Ethernet error. Those like blue lines are really the Ethernet error happens over time. Because Marvis continuously monitors the health state of each AP. When it see any AP experience this Ethernet error, Marvis will send actually a reset command from cloud, which will only takes a couple seconds, on the device to try to kind of recover the AP from the Ethernet error scenario. So you can see it's very interesting. The first AP, the Ethernet error disappeared after single reset. This is a self-driving case. It's self-driving auto recovery. The second one is interesting because it actually the Ethernet error disappeared for some time, then reassume, right? So that normally indicates the firmware problem, like say memory leak. So in that case, we actually can do an auto firmware upgrade. We're going to talk just right after this. The last example, this you can see the Ethernet error never disappeared in disregard of the reset actions. This indicates normally a hardware problem. This is the automated IMA we talk about, Bob and Sudheer talked. In this case, we do the proactive IMA, after we failed the remediation action from the cloud.
So how does RRM control the power in this case and not just go crazy by increasing the power? Because there is also an RRM factor to the coverage goal, right?
Yes, that's actually the self-driving piece, the reinforcement learning we're doing. So these are the two. It's our effort is always which is the parameters in the gradual way. That's a reinforcement learning. We don't change this suddenly to the optimal. We change that gradually and look at the feedback. Remember, we have this per minute user experience data to the cloud. We change it gradually. We look at the feedback. If it's on the positive side, we just enforce. If it's on the negative side, we cannot back up. So that's the self-driving piece. If we failed all of this self-driving, then the potential root cause can be the coverage hole, misplaced AP. So think of this. This is always self-driving. I'm not saying solve 100% problem. So that's the reason we have self-driving and assisted driving. All together, same thing for this Ethernet error. Self-driving will recover some of them, but actually at the end, you can see there's also some hardware failure that we cannot do. But my point is that we are going to take care of 100% of the case. We are going to really figure out the root cause and give you the corresponding action. This is actually a good, really showcase the power of the self-driving network. For all of the AP experiencing Ethernet error across the Mist universe, you see like 50% of them got remediated by that automated action. That's a self-driving. Another 40% of them got actually remediated by this firmware upgrade. We actually use to read the logs rather than waiting for domain expert to read the thousands of lines of the log to figure out the root cause, which normally takes like months of the time. Weeks or months of time for the traditional vendors. We actually use the NLP to read the call dumps, to read the backtrace from the log, and point that to an issue with the corresponding fix. So you can see with this auto firmware upgrade, which normally just take minutes from the detection to remediation, we can nuke another 40% of these problematic APs. What's remaining at the bottom, the hardware failures. In that case, we do the auto IMA for you. So all these three together cover almost 100% of this Ethernet error problem for all of the Mist APs.
The only point I want to make here is, when I actually got into solving this problem, the key here is taking ginseng and tying him to customer support. What that's really allowing us to do, and I would say we are the only vendor that's actually using AI to answer every support tick in our customer support team. And what that's really doing is turning the customer support model upside down, right? The days of you arguing with your vendor about whether or not you've got an RMA problem, those days are over, right? Your vendor now has the same information you have. They know when you're having a problem. So I think that was it, Sudheer. Just trying to highlight, this is really a very subtle point. People don't realize how cloud and AI is really changing the support model between customer and vendor going forward.
And if you really think about this, I know some of you are new to Mist Juniper. As Bob said, we measure every ticket and we take every ticket through the AI. And while we've had, obviously you can see the COVID dip here, but this is the total aggregated support tickets that come into the Mist universe. We've grown, about 200% in the number of organizations, about 280% in this time window here in terms of devices connected to our cloud. And in fact, our support tickets, even before COVID, have been flat to down. And this we attribute to fewer tickets coming into our customers, faster resolution and customers able to self-serve themselves, and faster deployment, faster troubleshooting modalities out there, right? So AI can truly impact customers, their customer help desk tickets, fewer, as Tim, I think you were talking about it, fewer escalations into network engineering, more solved at frontline help desk. But this is the impact. This is real, actual factual impact we're seeing where AI land for our customers.